All right, we're just going to dive into 2-3 day one. Hopefully you guys remember some of your algebra because more algebra is coming. So out of nowhere, we're still talking about real zeros. Now we've been talking about zeros, and that's where the graphs cross the x-axis, but this is more of an algebra. Find the zeros. So divide. Well, if you recall, there was a day where we used this strategy. It's called long division because it takes a long time. But it's not as bad as it looks. So the key to this is look at your first term here, and just let everything else kind of fall into place. So what times this gives me this? 2x squared. Now I like to put parentheses around that so I remember to multiply everything by it. 3. Almost a mistake right off the bat. So 3x squared. So we get 3x cubed minus 6x squared. Remember, we got to subtract it. Long division. So this minus itself, gone. Careful here. Negative 4x squared plus 6x squared would give us 2x squared. But because we have two things here, we need two things here. So we're going to bring the negative 9x down. And you get to do it again. You start with this first thing, but you look at this first thing. And you say, what times this gives me this? That'd be plus 2x. So I multiply both things. I get 2x squared minus 4x. Remember, you got to subtract all of it. So what's this minus itself? Gone. What's negative 9x plus 4x? That'd be negative 5x. I got to bring that negative 1 down. And I get to do it again. So what times this is this? Well, that would be negative 5. So we distribute, we get negative 5x plus 10, but we have to subtract. So we'd get this minus its, well, this negative 5x plus 5x is gone. Negative 1 minus 10 is negative 11. If you recall, that would always be the remainder. And the fraction form has to do with that. So my summary statement is my answer in fraction form, but my answer is this and this. Well, how do I put it together then? I go 3x squared plus 2x minus 5. I always like to put a plus no matter what it is. Negative 11 over the original divisor, which is here, x minus 2. And that's my answer in summary form. Fraction form, summary statement. Now, the reason we're doing that is to show you how nice this shortcut method is. And this you were taught in Algebra 2. It's just going to be a little bit of a blast from the past. So the first thing you do is you say, okay, well, that's the same problem, isn't it? So I'm going to show my work right down here. First thing you do is we're going to figure out what causes this to be 0. So what causes denom to equal 0? And the answer is x equals 2. And what you're going to do is you're going to put it right here. I call it the chipmunk nest. I don't know why I call it that. Maybe it's just so you guys can remember it. And then you take off the coefficients and you make a line. So 3, negative 4, negative 9, negative 1. Now, don't draw a line right underneath this stuff. Imagine there's a number here, a number here, a number here, a number here, and draw a line underneath all that. Then you take the first thing and you drop it beneath the line and you go like that. Then you start multiplying. 3 times 2 is 6. You bring it up there and then you add, which would be 2. And we multiply here. 2 times 2 is 4. Put it there and you add. 2 times negative 5, put it there, is negative 10. Then you add. You notice something? Look at my answer up here was 3x squared, 3, 2x, 2, minus 5, remainder negative 11, remainder negative 11. So this is mysteriously hiding the answer. And here's the trick. You see the highest power right there? It's a 3. You drop down 1 from there. So you say 3x squared plus 2x minus 5 and then plus negative 11 over my original divisor. And there's my answer. A lot easier than long division. Let's try another one. What causes this to be a 0? 3. Where do you put it? In the chipmunk nest. That's a line from Nacho Libre. And now I go take my coefficients off. 2, 1, negative 24, negative 10. Create a line, drop the first one below the line, and begin multiplying. So it's 6. You always add 7. And you multiply, 21, add. Multiply, then you add negative 19. What do I do with this? Find the highest power, and I drop down 1. So it's 2x squared plus 7x minus 3 plus negative 19 all over x minus 3. And there's my answer. Okay, this one's got a little twist in it, or else I'd skip it. So, first thing we do is we say, hey, what would cause that to be a 0? It would be negative 2. Put it in the nest. If you notice, this goes cubed squared to the first, nothing. Cubed squared to the first, nothing. See, it's in descending order. That's huge. What you need to do on this one is you need to imagine there's a 0y squared tucked in there. If you don't, this synthetic division is going to fail you. Okay? In other words, my list is not going to be 2, negative 9. It's going to be 2, then my 0, then my negative 9, then my 3, and then I get rolling. Drop the 2 underneath, multiply, add. Multiply, add. Multiply, add. And now because the highest power is a 3, I drop down 1. 2x squared minus 4x minus 1 plus 5 all over my original divisor, and I'm done. So I think you guys get the gist here. Now we got some interesting little formulas, and we just have to kind of decode it. So this says, the remainder theorem, if a polynomial f of x is divided by x minus k, in other words, k is a 0. Now I need you guys to really lock into that. So they're telling you, hey, this is one of your zeros. Then the remainder is r equals f of k. In other words, it's just a fancy thing saying find f of negative 2. In other words, put k in for x. Well, what's k? Negative 2. So they're just saying, plug it in. That's all they're saying. Fancy, fancy, fancy. And then it will just spit out the remainder. I'll explain what I mean by that in a minute. So if I plug that in, I get negative 2 cubed minus 3 times negative 2 plus 4. So it'd be negative 8 plus 6 plus 4. This is 10 minus 8, which is 2. What that's saying is, if I went like this, x cubed minus 3x plus 4, and because this is a 0, I would actually have x plus 2. And if I was to actually divide that out, I would get a remainder of 2. It's just a fancy little exercise to remind you of these functions, just plugging things in and letting it tell you something, okay? So, same thing here, plug it in, negative 1. So I gotta go negative 1. So negative 1 to the 5th, careful on that. Negative 2 times negative 1 to the 4th, careful on that. 3, negative 1 squared, minus 20 times negative 1 plus 3. Okay. So this is negative 1. This is positive 1 times negative 2 is negative 2. This is positive 1 times 3 is 3. This is negative 20 times negative 1, or plus 20 plus 3. Well, this all adds up to 26. This is negative 3, so that'd be 23. That's my remainder, using the remainder theorem. Now, this is called the factor theorem, which is very similar to the remainder theorem, but here's the deal. On these, they flat out give you the 0, and that's why you're able to just plug it in. On this one, It says use the factor theorem to determine if the first polynomial is a factor of the second. Well, for example, if I have 28 divided by 7 and I go, hey, that's 4. You see, I could say 7 is a factor of 28 because there is no remainder. So we're actually going to use the remainder theorem, but we got to use our noggin, because if we don't have a remainder, then it must be a factor. Well, here's the twist. If they say, hey, check into this, they're actually saying x equals -2 is our 0, and let's see if it goes into this evenly by just plugging in -2. You see this one, they just give you your 0. This one you have to think a tiny, tiny bit to figure out what your 0 is, then plug it in. So I'm going to go f of -2 equals -2 to the 4th minus 6 times -2 squared minus 10 times -2 plus 3. So what is this? Well, that's 16. This is 4 times -6, which is -24. This is plus 20 plus 3. So this plus this is 36, plus this is 39, minus 24, and I say 15 is my remainder, so I say that this is not a factor, because that's what we're really determining, okay? Now hopefully they give us one that actually works so we can see the difference. So what's our 0? X equals 3. So that means we're going to put that in right there. So we're going to find f of 3. We're going to see if there's a remainder or not. 3 cubed minus 3 squared minus 3 minus 15. Now the only thing I'm worried about is right here. Some of you might want to square that negative, but remember, this is subtraction. And if we remember our good friend PEMDAS, we do our exponent and then we do our subtraction last. So don't you dare square that negative. What's 3 cubed? 27 minus 9 minus 3 minus 15. Look at all this. Doesn't add up to -27. So what's 27 minus 27? 0. What does that mean? It means that this is a yes. It's a factor of that polynomial. It goes into it evenly, just like 7 goes into 28 evenly. All right, hope that makes a little bit of sense as you dive into your homework. Good luck.